So the basic derivatives are when you want to differentiate an expression. So if you want to differentiate the expression, let me call the expression expression. So you want to differentiate the expressions. The question is differentiate some expression. Now the word differentiate, the notation is d by dx, bracket open, you plug in the expression, bracket close. There is no such thing as d by dx equal to. This is a wrong derivative notation. So it is d by dx, bracket open, bracket close. Now the basic derivatives, when you differentiate something, you call the answer a derivative. That's what we call it. So when you differentiate something, d by dx of x to the power n, you write the exponent in front, then you reduce it by 1. For example, if I want to find the derivative of x squared, it would be 2 and then x. So the power of this would be reduced by 1. The derivative of x cubed is 3x squared. The derivative of x to the power 4 is 4x to the power 3. The derivative of x to the power 5 is 5x to the power 4, and on and on. But if you wrote x squared equals to 2x, it is completely wrong because x squared is not equal to twice x. We write d by dx of x squared equals to twice x, d by dx of x cubed equals to 3x squared, d by dx of x to the power 4 is 4x to the power 3, and d by dx of x to the power 5 is 5x to the power 4. This is how it works. So this is the basic derivative, and that is the basic derivative rule. Now the constant rule of derivative is that if you want to differentiate something and there is a constant multiplied to it, all you do, multiply the constant to the derivative. That's all. That means if you have 5x to the power 3 and the derivative is going to be, keep the 5 here, x cubed, the derivative is 3x squared, so the answer would be 5 multiplied by that, which is 15x squared. Or if you want to find the derivative of 10x to the power 7, you keep the constant multiplied with the derivative of x to the power 7, which is 7x to the power 6. We get 70x to the power 6. Remember, this is wrong unless we write d by dx of this, d by dx of this. So that's how it works. So one more common rule to remember is d by dx of any number x is always that number, because x means x to the power 1. So if you think of x to the power 1 as 1, x to the power 1 minus 1, which is x to the power 0, which is 1. So we get A. Another rule to remember is the constant. If you differentiate a constant, since differentiation means change, that would be 0. So that's how it works. Now how do you put it together? So usually expressions are added together. For example, I might have the question, you might have the question, differentiate x cubed plus 2x squared minus 7x plus 3. Now we know individually what to do, how to differentiate this. We know how to differentiate x cubed. It should be 3x squared. We know how to differentiate 2x squared. It should be 2. Derivative of x squared is twice x. So ultimately it would be 4x. We know the derivative of 7x should be 7 and the derivative of this is 0. But what about the plus and minus signs over here? Well, we have a special rule called the addition rule of derivative, or the addition subtraction rule of derivative. It doesn't matter. So addition rule. This is not a formula or anything. It's just a special rule. So when you have to differentiate expressions that are added together, well, the derivatives are the sum of the derivatives. That's it. So if it is minus, you put it in minus. So this is a very, very important rule of derivative. So let's do this. So differentiate means d by dx, bracket open, x cubed plus 2x squared minus 7x plus 3, and the derivative is going to be 3x squared plus 4x minus 7. So that's the derivative. Let's try another one. Differentiate x to the power 4 minus 7x to the power 3 plus 5x squared minus 7x plus 1. So differentiate means d by dx of bracket open minus 7x plus 1. Let's start differentiating. So x to the power 4 is 4 comes here. So remember, the power comes in front and the power is later on reduced. So 4x cubed. Now 7 is the constant. X cubed is differentiation 3x squared. This would be 5 twice x, and this would be minus x, and the differentiation of 1 is 0. No need to write that. So 4x cubed minus 21x squared plus 10x. So this is the derivative of that. Now let's do a little bit more difficult expressions. So let's try out these. Now the first one over here, so we have differentiate, so d by dx of 2. Now square root of x is x to the power half. That means the constant 2 will be multiplied to the derivative of x to the power half, which is half. X to the power n minus 1 is half minus 1. So this is 2 into half is 1. So x to the power half minus 1 is minus half. Now it's a very good idea, once you have differentiated something, to return the power to the positive form from the indices rule. So it would be 1 by x to the power half. The next one is a bit different. You see that 3 is upstairs, but x squared is a fraction. We cannot differentiate this. We have to divide it first. Now the rule for this is, we know the indices rule again. We have to bring this upstairs. So we have to write as x to the power minus 2. Now we are ready to differentiate. So let's differentiate this. So 3 is the constant. So this will be minus 2 x to the power minus 2 minus 1, which is minus 3. So now we can simplify minus 3 to the 6 x to the power minus 3. So the next one, we have differentiate d by dx of 1 by 3x cubed. Now, so we know we have to bring this upstairs. The common mistake is to write it as 3x to the power minus 3. But this is wrong, because 1 by 3 is really a constant. It is more or less like 1 by 3 into 1 by x cubed. We can only take the x cubed upstairs. We cannot take the 3 upstairs. So this is very important that you remember how this is written down. So this will be, let me erase this. So now we can write it as 1 by 3 into x to the power minus 3. So 1 by 3 is the constant. So x to the power minus 3, the derivative is going to be minus 3. X to the power minus 3 minus 1 is minus 4. So this 3 and this 3 cancels off. So we get minus 1 upstairs. And now let's try to make this positive. X to the power minus 4 by the indices rule is x to the power 4. So remember that. One more thing is important is when we are writing d by dx, as long as we are not differentiating but simplifying, we have to keep writing d by dx. It sort of means that we're simplifying. Okay, the next one over here, the two values are multiplied together. So d by dx of, this is 1 by 3 into x cubed into x minus 2. So we have to multiply this and simplify this before we can proceed. So this is going to be d by dx of, so 1 by 3, now x cubed into x is x to the power 4, minus 1 by 3, x cubed, this is into 2, so 2 by 3, x cubed, so this is going to be x to the power 3. Now we have simplified it. Now we are ready to differentiate it. So remember, we have to simplify it. To simplify means to add, subtract, multiply, divide. So 1 by 3 is the constant, and we can differentiate x to the power 4 as 4x cubed. Minus, now 2 by 3 is the constant, we can differentiate x cubed as 3x squared. To simplify this, we get 4 by 3 x to the power 3 minus this 3 and this 3 cancels, 2x squared. So that's the derivative. Let's do here a division. Let's do this one, number I. So d by dx of 2x cubed plus thrice x divided by square root of x. Now let's use some indices rule before we can simplify. So this is when you have division, so x to the power a divided by x to the power b, the indices rule says you subtract the power. So we have 2x cubed divided by x to the power half, because square root really means half, plus 3x divided by x to the power half. Now using the indices division rule, so we can write 2 is the constant, we can write x to the power 3 minus half plus, here we can write x to the power 1 minus half. Remember, we still haven't differentiated. So d by dx of 2 x to the power 3 minus half is going to be 3 to the 6, 6 minus 1, 5 by 2 plus 3 x to the power 1 minus half is going to be half. So now when we differentiate this, we can write here 2, and we can write the power in front, which is 5 by 2 x to the power 5 by 2 minus 1. So let me write it as 5 by 2 minus 1. I can simplify this later on, plus 3. So we can write this as half x to the power half minus 1. So that turns out to be 2 multiplied by 5 by 2. The 2 cancels and we get 5. And x to the power 5 by 2 minus 1. Now 5 by 2 is 2.5. 2.5 minus 1 is 1.5, which is 3 by 2. So this is going to be 3 by 2. Now plus, this is going to be 3 into half is 3 by 2. And we have x to the power half minus 1, which is minus half. So this is the derivative. Now let's do one more. Now we can try out this one over here. So d by dx of thrice x minus 2, 4x plus 1 by x. So what we can do here, we can multiply this. So we can simplify. Remember, as long as you're simplifying, you have to keep writing d by dx. So thrice x into 4x is 4 3 is 12 x squared plus thrice x into 1 by x. So it is going to be thrice x divided by x, or only 3. Next, minus 2 into 4x is 8x minus 2 into 1 by x is 2 by x. So now let's differentiate this, but before that we have to make sure all the variables are upstairs. So 12x squared plus 3 minus 8x minus 2 x to the power minus 1. Now we are good to go. So this is going to be 12. X squared is going to be twice x. That's the derivative. The derivative of 3 is 0 because it's a constant. The derivative of minus 8x is minus 8. Then minus 2. The derivative of x to the power minus 1 is minus 1 x to the power minus 2. So we can now write 24x minus 8 minus 2 into minus 1 is plus 2 x to the power minus 2. Let's make it positive x squared.